Okay, good morning. Today I'm here to present to you the D-CreEA DSML for creating educational analog card games. My name is Rubens Silva, and the second author is Rossana Andrade. This is SBGames from 2021, and yeah, let's go. Here are the summary of this work, and first I will introduce you to the motivation. We have MDA, which is model-driven engineering. And MDA is one way to promote an effective system development approach through software frameworks and meta-model structures. The main factor of this method is the creation of models. In MDA, we create model of games, not the game itself. So if I want to create the game, I will have to manipulate the model and then translate it to the final code, which can be analog or digital game. These models bases the development of the real systems. They aid the process of concept, build, and prototype in a standardized and semi-automated way. However, these models define specific software to specific domain problems. So if my problem is a little bit outside the domain of the DSML, the model generated can be not so effective or effective at all. So how do we use this approach to develop games? In our research, many MDA approaches create game meta models in many domains as educational games inside many knowledge fields. Some of them create only the UML models. Some others create the full game from the model, aid with the translation software called model to artifact. However, all the domains found reside only on digital games. None of them focus on analog or hybrid games. So with this work proposes an MDA approach to develop analog educational card games, called D-CreEA Card Games. So here I have some statements of this research. The motivation is the lack of the DSML approaches for educational analog games itself. The research question is how to create an educational analog card game grounded on game design approach aided by the software engineering. With this, the expected contributions is to provide an approach to generalize educational analog card games for non-experts on game design with personalized educational content. And also, we expect to promote the discussion about the MDA approach for analog games. Talking a bit more about the target audience, the computer science professors whose subject contents can be translated into unitary questions and answers, so that each question has one or a set of defined answers, and the teacher has the role of developing the game. So the mechanics and dynamics in accordance with the educational objectives. However, the teacher does not need to have expertise in games to do this. All you need to do is follow the step-by-step instructions and use the software tool to implement the game. The gameplay will have the quiz as the most basic game mechanic, which is the questions and answers described by the teacher. However, other main and secondary mechanics can be part of the repertoire, such as trading, deck, take-that, card drafting, RPG, and many others. So here I present the method for developing the DSML. The domain phase consists on two types of development, which is top-down and bottom-up. The top-down research for generalizations of educational games, and the bottom-up research for analog games. And this joint generated the domain of this DSML. With the domain defined, we developed the target model, the abstract syntax, and the static semantics. With this, we defined the model to artifacts conversion, and then we evaluated it. So here are the domain and abstract syntax. Use class diagram to represent the abstract syntax. So here we have all the classes that defines the domain of the educational analog card games. So to ease the process for non-experts, we designed a model template in UML for a simple game loop, and this model can be extended to another game from the perspective of the professor. With this, the user can manipulate and generate the personalized rules, cards, info, and also understand better the way to generate the game itself. according with on context, avoiding the need to start from scratch. This code is in JSON, which is a simple to manipulate text data structure. And as a future work, we want to develop a software web interface to facilitate the process of modeling, creating, and download the game itself. So it will be not necessary to manipulate the code of the game, but only the interface. So here we have the template game loop. As you can see, we have some rectangles, which are the states of the game. And each rectangle has some arrows. There are the rules of each state. So each state has a purpose, has a meaning. So it encapsulates all the rules for that meaning. As an example, here we have play a challenge, which have all the rules for playing a challenge. Also, we have some special diamond-shaped state, which is attached to a regular state. And this diamond means a condition to go to a stage or to another state. And this choice depends on the game context and the moment of the game while playing. So the loop goes on from play or next player, and the game is over if the game ending condition is satisfied. So here we're going to talk about the evaluation. We want to test the suitability of this approach. The evaluation of this DSML aims to show whether the tool is suitable. For this, a version of the educational game D-CreEA Card Game was developed. The D-CreEA is an educational analog card game that aims to practice the study of software testing. The gameplay consists in identifying the type of software test that was used on the given scenario. So it will act as the challenge of the game. And if the player can catch bugs with the game cards, he or she wins a point. This game was chosen due to its different types of game mechanics as negotiation, bonus, and since those types of gameplay were not included on the basic model of D-CreEA. So here we have the game, the D-CreEA Card Game loop. It's very similar to the template. However, we have a third loop, which is negotiate with players, where we define the negotiation rules for the game. And if the negotiations are well or not, they go to play next player, the player can choose to play challenge, play bonus, or next player. So here I have the code from the demo, and by now it's only for testing in Angular. So it is necessary to compile the projects and run it from the local host. But basically we have here the game model and all the information from the game. So if we manipulate this and we go to the browser, so here in the browser we have the web page on the local host. So if we run this demo and see the game, we can check here the manual of the game, the game info, the deck explanation, and the game rules that was generated from that UML diagram. So if we want to print the game, we can check here that it was generated separately, the cards and the game manual. So the game manual has all that info, so as the cards from the deck. So now we have the final remarks. This work presents the D-CreEA, a domain-specific modeling language to aid the development of analogic educational card games. Is the SML a suitable approach to generate analog games? Well, I think we cannot answer this with 100% sure, because it's necessary to show much more evidence that prove or disprove the efficacy or the efficiency of this type of method for this problem. However, with this work, it was possible to implement a published educational analog card game and even improve it with relative easily. Also, it's possible to implement a whole variety of games, since the model of the game loop can easily be extended to any type of rule and therefore to other analog mechanics. Although it's necessary to improve the evaluation, this is an initial step towards the direction of MDA for analog games. And as future work, we will evaluate the DSML with professors, students, and game designers in order to improve the correctness and completeness in providing a useful tool. Furthermore, we will implement a web SaaS application based on the DSML to ease the process of modeling and downloading of the games. Here are some references, and thank you